Now, in this video, we will going to take up one more problem on projections of lines, how to analyze by using three-dimensional sketch and also how to write it by using a sketchbook. So the problem number 66, the top view, it reads as the top view, capital PQ of a straight line is 70 mm and makes an angle of 60 degree with XY line. The end capital Q is 10 mm above HP and 45 mm in front of VP. The difference between the distances of capital P and Q above HP is 45 mm. Draw the projections, determine its true length and true inclination with HP and VP. So to do that, so first we are going to take the NQ, which is 10 mm above HP and 30 mm in front of VP. So when you look from the front view, we can see the distance above HP. That distance is seen in VP. So as we look from the front view, the image will going to fall on the vertical plane, which is Q dash, and this is capital Q. And similarly, when you look from the top view, we can see the distance 30 mm in front of VP. That image will going to fall on the vertical horizontal plane. So that distance is capital Q here. So this is small q. So NQ is 30 mm in front of VP. And then as it says that the difference between the distances of capital P and Q is 45 mm. So from here you measure 45 mm. From Q you measure 45 mm and draw a horizontal dash dot line so that you will going to get the locus of P in the front view. And then the top view PQ of a straight line 70 mm makes an angle of 60 degree with XY line. So from small q you measure an angle of 60 degree and draw an inclined line at an angle of 70, so that at a distance of 70. So 70 mm to an angle of 60 degrees, so that you will going to get a dash dot line which will going to be small p, and this will going to be the locus of Q. Then join Q and P with a dot line. And similarly, now as we got the top view now, so once you got the top view, so draw a vertical projector from here till here, and then from here you draw a vertical projector to the front view, so that you will going to get P dash. Then join P dash and Q dash with a dark line. So when you are projecting from P dash and also from P, both will going to intersect at this point. So now you will going to get the point which is in space, which is capital P and Q. But this will not be there in your orthographic view. But this is how, when we are doing it in 3 dimension, we will be able to get the line in space. This is the actual position of the line. When you are looking from the front view, that image will going to be P dash Q dash, and when you look from the top view, that image will going to be P and Q is here. So now what we need to do is we need to find out the true length in the vertical plane and as well as in the horizontal plane. So to do that, with capital Q as center, taking the radius of QP, you rotate it such that both Q and capital Q and P1 are in front of VP by 30 mm. Now the line is parallel to VP. So as we are rotating in space, what happens? The image which will be there in the top view, which is Q and P, becomes parallel to VP. So both small q and small p1 are in front of VP by 30 mm. So now the line is parallel to VP. Once the line is parallel to VP, so we are getting the true length in the vertical plane. So that is the this is the line that capital QP1 is the line which is in true length. So how do I project? So when you look from the top view, that projection takes place in the horizontal plane till here, and when you look from the front view, that projection which was here will going to be projected from here to the locus of P in the front view. So mark this point as P1 dash. Then join Q dash P1 dash with a little bit thicker than the XY line, and you mark this point as P1. So this is our capital Q and capital P1. So now the line is in true length. So measure the inclination theta here. Similarly, when you are trying to find out the true length in the horizontal plane, so how to find out that? With capital Q as center, taking the radius of QP, draw an arc such that both Q and rotate this line Q and P1 such that both Q and P2 are above HP by 10 mm. So this is the line when it becomes parallel to HP. So when you are looking from the top view, that image will going to fall on QP2. So this is the line which is in true length. So when you are looking from the front view, what happens to the rotation of the line in space? Obviously from Q dash, you take the radius, and both Q dash and P2 dash are above HP by 10 mm. So that is the line which will going to be parallel to HP. So once the line is parallel to HP, so you are getting the true length in the horizontal plane. So as we are looking from the top, as we are looking from the front view, that projection will going to take place from here to here. As we look from the top view, that projection will start from here and then till it comes to the locus of, till it touches the locus of P in the top view. And you mark this point as small qp2. Then this is the angle true inclination qp2 with little bit thicker than the xy line. So the true inclination with respect to VP is fine. And this is how we can be able to analyze this problem in three-dimensional analysis. Now we will try to solve. Now we are going to try to analyze in steps. In the first case, as we are trying to find out the true length in the vertical plane. Once you get this QP, you make it parallel. You rotate this, make it parallel to VP. So as we are doing that, what happens? Top view line is made parallel. So correspondingly, this will going to be in the true line. So how I can do it in the orthographic view? With Q as center, taking the radius of QP, you rotate it and make it parallel. So QP1 is the line which is parallel to XY in the top view. Correspondingly, in the front view, so you are projecting this. So P1 dash is here. So this is Q dash. Q dash P1 dash is the line which is in true line. So capital Q and capital P. Similarly, when you are finding out the true length in the horizontal plane, with capital Q as center, taking the radius of QP, you rotate it and make it parallel. Both QP2 is above HP by 10 mm. So what happens in the image in the vertical plane also, that Q dash P dash is the image which is the top front view which is being rotated, such that both Q dash and P2 dash are above HP by 10 mm. So now the line is parallel to HP. So you are projecting this, and when you are projecting to the locus of P in the top view, so QP2 is the line which will going to be the true length. As we look from the top view, that has been projected here. So the projection is done from here to here. And then when you look from the top view, that projection is shown here. So that both Q and P2 is joined together. And this is the inclination made by that with respect to VP. So when you are doing it in, when you are showing it in orthographic view, you make that front view line parallel. That is both Q dash and P2 dash are above HP by 10 mm. And when you are projecting that P2 into the locus of P in the top view, you mark this point as small p2, then join Q and P2 with little bit thicker than the XY line. So as we know that the front view line is parallel, correspondingly its top view will be in true line. So Q and P in brackets. So this is how you can be able to analyze in 3D and also by using the orthographic view. Now we will try to solve this problem by using the sketch flow. So to do that, first we are going to take the XY line and you mark VP and HP. Then from XY line, you measure 10 mm above XY line and then draw a horizontal line. And similarly with from XY line, you measure 30 mm and draw one more horizontal line. Consider any point on this and you draw a vertical projector. So you mark this point as Q dash and also as capital Q. You mark this point as Q and also as capital Q, both in the front view and also in the top view. Now, as he says that the top view line makes 60 degree with XY line being 70 mm. So by using the protractor with Q as center, measure an angle of 60 degrees and draw an inclined line which is below XY line. Then by using the compass with Q as center, taking the radius of 70, cut an arc on this 60 degree line and you mark this point as small p, then join Q and P with a dot line. So then draw a horizontal dash dot line and you mark this as locus of P in the top view. Now, as you know that the difference between the distances of capital P and capital Q is 45 mm. So you have capital Q here. So difference means from XY line 10 mm. So from XY line you measure 55. So 55 minus 10 will become 45. Difference between Q and P. So this is capital P and this is capital Q. That above HP is 45. So this distance will going to be 45 mm. So from XY line it will be 55. 55 minus 10 will going to become 45. Then draw a horizontal dash dot line which will going to be the locus of P in the front view. So then you know the locus of P in the top view and as well as in the front view, and you have the top view point small p. So from P you draw a vertical projector such that it will going to cut the locus of P in the front view, and you mark this point as P dash and join P dash Q dash with a dot line and also Q and P with a dot line. Now by using the compass with Q as center, taking the radius of QP, you draw an arc such that both Q and P1 becomes parallel to XY line in the top view. In other words, both Q and P1 will be in front of VP by 30 mm. So from P1 you draw a vertical projector such that it will going to cut the locus of P in the front view, and you mark this point as P1 dash. As the top view line is parallel, so its corresponding line will be in true length, and you mark this point as capital P. Join Q dash and P1 dash with little bit thicker than the XY line. So and mark this angle as theta. Similarly, with Q dash as center, taking the radius of Q dash P dash by using the compass, you draw an arc such that both Q dash and P2 dash are above HP by 10 mm. So now the front view line becomes parallel. So it's correspondingly the top view will going to be in the true length. So from P2 dash you draw a vertical projector to the top view such that it will going to cut the locus of P in the top view, and you mark this point as P2. As we know that the front view line is parallel, its corresponding top view, that is Q and P2, will be in true length. So you mark this point as capital P. Join Q and P2 with little bit thicker than the XY line, and you mark this angle as phi. Then using the scale, you measure the true length, which will be Q dash P1 dash, which will be true length, which is 83.83 mm in manual, and also when you measure Q and P2, that also shows 83 mm only. So that means the true length in the front view as well as in the top view will going to remain the same. Similarly, by using the protractor with Q dash center, measure the angle theta, which will be 33 degrees, and with small q as center, measure the angle by using the protractor, which will going to be phi, which will be 47 degrees. So when you are doing it in computer, the true length will be 83.2 mm, 22 mm, and phi will be equal to 46.76 degrees, and theta will be equal to 32.74 degrees. So this is how, and mark all other dimensions, and this is how you will be able to solve this problem by using the sketchbook. Thank you.